Hey. Oh, there I am. Hey guys. All right. So we went into some fairly complicated math the last time, and we're going to continue on with this coming up time. We talked about all the different properties, associative properties, and distributive properties, and commutative properties, and so forth. And we talked about expressions and terms and constants and coefficients and exponents. And I really am thrilled because I love this part of math. This is my favorite stuff, getting into it. But I want to review a little bit first. So we're going to talk about that. We're going to say right here, let's see, in this 6x plus 4, first off, this right here is a term. Okay? The 6, whoopsie. See, this is where I need to have this on. There we go. This is the coefficient. The x is the variable. And the 4 is a constant. Okay, so we went over all this last time. So just so you know, this is just pretty much review because we're going to be going into it a lot more over this lesson. Okay. Now, we're going to talk about like terms. So, of course, we talked about terms as it says a term is a number by itself or the product of a number and a variable. Terms in a math sentence are separated by a plus sign or a symbol. So when this right here, when it said 6x plus 4, this was a term and this is a term and it's separated by this x. Okay, so a number by itself or a number multiplied by a variable is a term. These are both terms. Okay. Good. Now, for this, if you have your blue book, I'm going to tell you that it's a good idea to have it close. I didn't want to do that. Have it close because you're going to need two things. One, your divisibility rules, and two, your prime number sheets. Okay, so we're going to go ahead and get started, and the way you're going to be using this is to help you to factor it out. Now, a lot of books will tell you that it's not important to factor in numerical order, and it isn't because of the associative properties of multiplication. It doesn't matter what order you put your numbers in when you're multiplying them, but as you get more into putting like terms together, having those numbers in numerical order is going to make a big difference for you. So I encourage you to do it the way I'm asking you to do it, which is to start off with your 2's and go down the line. So to start with prime factorization, we start with a number. Let's try turning on this camera again. Let's try 162. Okay, now what we do is we start off right here. We have two lines. we know, because we're going to go through our divisibility rules, that if a number is divisible by 2, it is an even number. And so we can do that. And 162 ends in an even number, so it's even. So we can start off with a 2. And then we divide that 162 by 2. 162 divided by 2 is 81. Now we go to the 81. Is 81 an even number? No, it's not. But if we go to our divisibility rules, we see that if the sum of its digits is divisible by 3, then it's divisible by 3. If you add 8 and 1 together, that means that it's 9, and 9 is divisible by 3. So when we do this, we're going to put a 3 here, and 81 divided by 3 is, I don't know for sure right now, so let's do this. 81 divided by 3, 3 divided by 8 is 2. 2 times 3 is 6. I'm going to subtract. 8 minus 6 is 2. And 3, I'm going to drop the 1. 3 goes into 21 7 times. So 27 is right here. 27 is also not even. You're not going to have any more even numbers from here on out. Once you stop having even numbers, you don't have them anymore. So we're going to stick with the 3 and see if we can add 2 and 7 together and get something that is divisible by 3. 2 plus 7 is 9, which is divisible by 3. So we're going to put a 3 right here. And 3 goes into 27 9 times. And of course, 9 is divisible by 3 and 3. So our prime factors for 162 are 2 times 3 times 3 times 3 times 3. Okay, now the fun part is this. We are going to combine our like terms. Remember, a term is any number that's by itself or any number that has a that is multiplied by a variable. Now remember too that when we're getting into the more complex terms, we're not going to be using an x for multiplication anymore. We're going to be using our dots. So these are all terms, and we're going to combine them together. This says 2 times 3 times 3 times 3 times 3. And what we're going to do is we're going to combine those multiples of 3 into one term that has an exponent. And we're going to be doing that by counting them. 1, 2, 3, 4. It's 3. And we're going to have an exponent right there. That exponent means that you're multiplying that 3 4 times. 3, not 3 times 4, but 3 times itself 4 times. And then that 2. So this right here is the same as this. And this is the same as that. Okay, let's try it again. Okay, what's another good number that we can prime factorize here? Let me see if I can find some that are going to be things that are going to have to work at it a little bit. Hold on, give me a minute. I'll pull some up that are going to be really good. It doesn't have a lot. Well, let's try something fun. Let's see what it gets us. Let's try 112. 112. Well, right off the bat, we can see that it is divisible by 2 because it ends in an even number. So 2. 112 divided by 2. 5 times 2 is 10 right here. We're going to subtract. 2 goes into 12 6 times. So this right here is 56. And then we can see that that is still an even number. 6 is an even number, so the number is even. We have 2. And again, 56 divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. We're going to subtract 5 minus 4 is 1. 6, bring it down. This is going to be 8. So this is going to be a good one. So this is 28. From here, I think I can do it on my own. I think. Let's see here. Yeah. Okay, still even. So we're going to use another 2. And then this is going to be 14. I can see it real quick because the 2 goes into 2 one time and the 2 goes into 8 4 times. Still even. So we're going to put another 2. And 2 times what equals 14? That's right, 7. So our thing adds up to a dead pen. 2 times 2 times 2 times 2 times 7. 1, 2, 3, 4. 1, 2, 3, 4, and then 7. And because it is 2 times 2 times 2 times 2, not 2 times 4, 2 times 4 is 8. 2 times 2 times 2 times 2, let's see here. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 7 is 112. So it's very different from 10 times or 2 times 4. So 2 times 2 times 2 times 2 is going to be 2 to the 4th power times 7. That equals this, and that equals that. Okay. So I think you've got the idea of prime factorization. I don't think it should be difficult from here on out, but it will be part of what we're going to be doing. So I'm going to move on now to other stuff. So like terms, so when we're talking about 2 times 3, these are like terms because they're both single numbers. But if we have 2x times 3, these are not like terms because this is 2 times x. This has an x on it that we don't know the value of. So we can't say that this is going to be the same as this. Those are two different terms. Okay. Likewise, if this is 3xy, this is going to be a different term from this because it's got two variables on it. It could be unknown, they're unknown values. So we can't say that this is the same as this. Also, if this right here, 2x times 3x, these are like values. And if you were going to combine them, you would multiply. Well, actually, you don't. We're not multiplying. We're combining at this point, xing or adding. So you can add these two together, and they would be 5x. Okay, the term itself stays the same. These numbers are like. However, you cannot add something like this, 2x squared plus 3x, because that squared part makes it a term that we don't know. So we can't combine it to something else that we also don't know. However, we can multiply them. Now let's back up a step. Now, when you're adding, similar to fractions, when you're adding fractions together, the denominator stays the same. When you're adding terms, the variable stays the same. They have to be a like term, and they will stay the same when you add them together. Your sum will have the same term. However, if you multiply it, that changes things. You multiply your numbers, so that equals 6, but you also multiply your x times x. Now, since we don't know the value of the x, we have to do the same thing like we did when we put the 2 times 2, which equals the 2 to the second power, or 2 squared. We have x squared. Okay? Now, we can't add these two together because they don't have like terms. However, we can multiply them. We have our 2 times our 3 is 6, and then our x squared times x, we just add our variables together, our variable exponents together, not the variables. When you have an x by itself, 1 is implied, just like everything else that is, like if you have an x here, 1 is implied as a multiple. 1 is an implied exponent when it's by itself. So you add your exponents together to become x to the third. Don't be confused. It's not that bad. You'll be fine. I promise. Okay, so we're going to back up a little bit. Get some terms down, some vocab. Okay. So all these things that I'm going to show you are actually terms. They all are numbers by themselves, or numbers that are multiplied by a variable in some form or another. So 5, that is a term. X, it's a variable, but actually it's also a term because 1 is implied. Remember that. 7, Y, that is a term. It's a number and a variable. Also, 16, M and N squared. 16 M N squared. Lots of terms, or lots of things on there, but it's still a single term. A number and more than one variable. So in an expression, which is when you're showing, add or subtract or any sort of operation with these terms, terms are separated by an addition calculation which may appear as a positive or negative sign. So I think I told you guys this at some point, but I'm going to actually write it down and show you what I mean. So in an expression, let me put this in purple so it's nice and big and bold. In an expression, terms are separated by an addition calculation which may appear as a positive man, as a positive or negative sign. Now, what does that mean? In an expression, terms are separated by an addition calculation, which may appear as a positive or negative sign. Well, hold on, Miss Scott. Doesn't it just mean that we're subtracting if we're using a negative sign? Yes. However, because we're combining like terms, it's ever so much easier if you just consider everything to be an addition. You're adding everything together, but sometimes you're adding negative numbers rather than subtracting. So let's say we have 2 plus negative, 2 minus 6. Now, we could just say it's equal to negative 4. And in most cases, if we're just doing these like terms and they're just numbers, it may be easier just to leave it that way. But I want you to get into the habit of saying from now on, we don't subtract, we add negative numbers. So 2 plus negative 6 equals negative 4. It's the same thing. You're still just doing the exact same operation, more or less, but what you're doing is you're adding a negative number so that that negative number tells you which direction to go, for one thing. But when you have a big long line of terms and you have to kind of rearrange stuff to make it all make sense, it's easier to know that you're doing adding a negative number rather than having to take out an entire sign and have to figure out what sign is supposed to be there in its place. So if you have 5 plus 8y minus 4 minus 5y plus 6mn minus 3. And we have to combine all those terms together. Well, we have to find the like ones first. The like ones, let's start with the easiest ones, the ones that are just simply the numbers. We can't just take this 4 and put it 5 and then 4. And it would be even more difficult to say, let's go ahead and take this and subtract the 4 because we know that that's what that is. But then what do we leave as the sign in its place? Because we're taking out the operation right here. So we're going to go ahead and do that. And instead of doing that, we're going to put it plus here and negative here. So that way, we know that when we take out this sign, we can just connect the dots that way. So we're going to do plus negative 4. Same thing here. Rather than do a negative, we're going to do a plus. And instead of a minus, we're going to do a plus negative 3. So we just take that right here, and we know that that negative 3 is going to go right here. Okay, so now we have 5 plus negative 4, which is going to be, at that point, it's going to be 1 plus negative 3, which is going to put us at negative 2. So when we've combined all of those, we're going to have negative 2, not negative 7, negative 2. And we can take out that, and we can take out that, and we can take out that. And then we're going to combine. We took out that was right here. This was right here. Now we're going to combine our terms that have a y. So we're going to put a plus here because we're not subtracting anymore, but we are dealing with negative numbers. So we have here a positive 8y, and instead of minus 5y, we're going to do plus negative 5y. And that's, when we take that out, that's going to leave a positive 6mn. So we know what that sign is going to be as well. So 8y plus negative 5y is going to be 3y. And then that's gone and that's gone. So all we have left is a positive 6mn. I know that was looking kind of convoluted, but you'll get the idea as we go along. There is a very specific reason why we do that, and that is because when we're combining like terms, it's less complicated to make everything that says minus into a negative number rather and add it. And you'll see as we go along how that's true. Okay. I want you somewhere in a notebook to write this down. In an expression, terms are separated by an addition calculation, meaning that you're going to add it together, which may appear as a positive or negative sign. So we're going to add numbers together, whether it's a positive number or a negative number, we're always adding those together. That is a rule from here on out. Okay, so I have right here an example of 5x plus 3y plus 12. The terms are 5x and 3y and 12. And yeah, that's just showing you the different terms. And then we have 3g squared plus 47h. And then it says here minus 19, but then it makes the note to say the terms, although you may look, this may look like a subtraction symbol, you're actually adding a negative number. So what we're going to do, whenever we see a subtraction thing in a problem, we're going to take that out. We're going to put a plus sign and turn the number itself into a negative. Okay. So that way, if we're combining these and there's like terms, we're going to do this as a negative number, adding a negative number. Okay. In order to simplify an expression that has multiple terms, like we did just a little bit ago, we rewrite the expression so that it contains fewer numbers, variables, and operations. Basically, you make it look more simple. So, for instance, Denise has 6 apples in her basket. Let's call each apple A. Okay, so A equals each apple. We could express this as A plus A, if we had like a, let's see here, see how my drawing skills are. Basket, crosshatch, 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 and then apples. Apple, 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 apple. So I just put in there 8 apples. So we could express it as A plus A plus A plus A plus A plus A plus A. We could do that, but wouldn't it be simpler just to put all these together? 1, 2, 3, 4, 5, 6, 7, 8. Now remember, when we were combining before, we were doing multiplication. This is addition. And every A has an invisible 1 in front of it. So when we're adding up or combining these like terms, we're not adding the A's, we're adding the 1s. 1, 2, 3, 4, 5, 6, 7, 8. So then that becomes 8A, or 8 times A. So when we put all the a's together to get 8a, we are collecting like terms. Each term has the variable a. I'm going to take those ones off because we don't need them, because we're big kids and we know that anything in front of a variable has an implied 1. Each term is a variable a, so we can combine them with the coefficient of 8, which tells us how many a's we have. There are 8 a's. When combining terms with the same variable, add the coefficients. So this is a rule of combining like terms. When combining terms, with the same variable, add the coefficients. Which is exactly what I've been telling you. So when you have the same variable, the same part of that, you add the coefficients, which is this right here. Now, what happens if we had 7 apples in a pear? So we had a plus 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 ab. What would we have there? Well, we'd have 1, 2, 3, 4, 5, 6, 7 a's plus that ab, which is a pair. It is not a like term. Okay? Okay, I hope this is making sense to you guys. The hardest thing about trying to teach you on the computer, on the video, is that I'm not getting any feedback. And when I say, are you with me? You guys can't say yes or no or boo or whatever. Okay. So now let's say Denise has 3 different baskets. She's got a pink basket. Let's not do pink with a green. Let's see if we can find a pink. Here we go. She's got a pink basket. And she's got a purple basket. That's the basket. And she's got a green basket. How's that? Let's see if we can do a little bit better with our baskets. A little bit better. Okay. And in our baskets, she has 7 in this one, and 1 in this one, and 5 in this one. So we know 7a plus 1a. We don't have to write the 1 because we know that if it's just 1, you can just write the variable, plus 5a. And we're going to combine all these together. 7 plus 1 plus 5 is going to be 13. And we're adding, so the variable does not change. 13a. Okay? So much stuff to learn. Da, 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 da. Okay. So a variable without a coefficient actually has a coefficient of 1, as I've been saying. So m really means 1m, and k really means 1k. So remember, the identity property of multiplication is anything times 1 is still the same, right? So, yeah. Okay. If two terms do not have the exact same variable, they cannot be combined. So here is, let's get rid of all these funky baskets. Funky basket. 7m plus 3y minus 2m, except because we don't subtract anymore, right? We add negative 2m. Plus y plus 8. Okay, take a look at that for a minute and see if you can't figure out which ones are the like terms. I'm going to say these right here, 7m and 2m. And so when we bring these down, 7m plus negative 2m, you're going to get 5m. So you're going to start off with 5m plus. Our next terms that we're going to combine are going to be this one, 3y plus y. 3y plus y equals, take a guess, what do you think? 4y. Because remember, you have an invisible 1 in front of that. Okay, so plus 4y. And we have taken out this one and this one, this one and this one, and all that's left is plus 8. I should have made that a pretty different color. Let's try the new plus 8. There we go. Okay. So far we're having fun with the combining the like terms and stuff. Let's go keep it going. Okay. Remember, a term with a variable cannot be combined with a constant because they're not like terms. Okay, you have to, like you can't combine this 4y and this 8 because these are not like terms. That y makes that 4 a different term entirely. Also, though, because of the associative property of multiplication, 3ab can be combined with 2ba. Now, normally, mathematicians would very rarely write BA because they almost always will put their letters in alphabetical order. But the point is that A times B, and B times A are exactly the same thing. So you're going to combine it, you're going to have 5, and then you're just going to fix that whole alphabetical thing on your own. A, B. Okay? All right, when simplifying, we often put the term with the greatest exponent first, and we put the constant last. This is called descending order. So this goes along the same lines as making sure that your exponents are in alphabetical order, because in all things, especially and particularly in math, there is an order. One of these days, I'm going to explain to you the order of adjectives. You're going to have your mind blown by that. Okay, so when simplifying, we often put the term with the greatest exponent first, and we put the constant last. This is called descending order. And it also says mathematicians tend to put their variables in alphabetical order. Smart I am, I'm so smart. Okay, so we take the term or the expression 7m squared plus 2m minus, because we don't subtract, plus -6. Now, m squared, by definition, is going to be bigger than m. Therefore, just about anything that you're going to have in front of m squared is going to be bigger than m. Because as we know, m squared, m with the exponent of 2, is m times m. Okay? So when you have, like, say, if the value of m was 100, you're going to have this is going to be 100, 2 times 100, which would be 200, but this is going to be 7 times 100 times 100, which is actually 10,000 times 7, which would be 70,000. So anything that's got the exponents on there is going to be bigger than the stuff that doesn't. So you're going to have that listed first. And of course, the 6 doesn't have any exponents, so it's going to be listed last. The -6 is what? Constant. Okay, what else do we need to know here? Sometimes we need to use the distributive property first before we can combine our like terms. So let's take a look at this. We have 3x plus 4 parentheses x plus 3 plus -1. Now, here's where you start worrying about order of operations. Okay, so we're going to break that down for you real quick. Let's see, where's a good color for that? Will this orange be nice and big? Order of operations. So, all this time, you guys have been doing your order of operations, but really the only parts you've been worrying about has been the last part of it. So we have, please excuse my dear Aunt Sally. And mostly you guys have just been worrying about this bottom part, which stands for multiplication, division, addition, and subtraction. And so in your order of operations, when you do stuff, you have to go through all of your big problems. To solve them, you do your multiplication and division, do all that, and then you go back through your problem and solve it again using addition and subtraction. There. But now we need to know how to incorporate these other two. The first one is parentheses. I'm going to show you a little English secret. These are actually parentheses. So parenthesis is 1, parentheses is multiple. It's kind of the same as, I don't know, it escaped me right for the second, but it'll hit me again and I'll tell you. And then this one is exponents. So first, you go through your thing and you solve out your parentheses, and then you solve out your exponents, and then you solve out your multiplication and division, And then you solve out your addition and subtraction. So when you have something like this, the first thing you're going to do is you're going to solve this part out right here. And remember, this is using the commutative property of multiplication. So we're going to bring this out here. 4 parentheses x plus 3 end parentheses. And we're going to take this 4 and we're going to multiply it by x. And we're going to take that 4 and we're going to multiply it by 3. And because our sign is plus, it's going to be an addition expression. So 4 times x is 4x. We drop our sign down, so it's plus. 4 times 3 is 12. So now we're going to take this part of it and stick it right there where this was. So now we have 3x plus 4x plus 12 plus -1. And now we go through and we look for our like terms. Our like terms are 3x and 4x. So we add those together to make 7x. And then we're going to be adding the sum of this, 12 plus -1. 12 plus, but we're going to go that way because that's what the negative sign is telling us. So we're going to go one spot that way, which is 11. So this is this. This is this. How do you like them apples? I don't know about y'all, but I'm having a great time. Great time. Okay, so let's try another, shall we? Let's see here. Oh, that didn't look good at all. Okay, so this is not a good pen for this board. I'm going to take some. Okay, hold on just a second. I'll be right back. I'm back. Oh, wow, look at all that shine out there. Let's see if we can't fix that. Nope, nope, that didn't help. That's a little bit better. Oh. Okay. So, wow, that blue does not wish to let go. That's a bummer. Okay, well, I threw it out. So hopefully that will help. So I'll use it again. Okay. So let us do a couple more here. Let's do 3t plus 6z. Now it says minus 4t, but of course we're not going to do that. We're going to add a negative 4t plus 9z plus z. Okay. So I'm going to give you a minute to look at that and decide what it is you think you should do with this. Well, if it were me, I would recognize first that there are T's and Z's, and T comes first in the alphabet. So we're going to have that come first in our answer. So we have a 3T and a negative 4T. So when we combine a 3 and a negative 4, you would get a negative 1. So negative 1T. But again, we don't have to have that one there. Okay? Because we are big boys and girls and we know that the 1 is already assumed. So it's negative T. But you didn't know you could do that, did you? So that takes this out and this out. And so now all we have left are Z terms. So we have 6Z plus 9Z plus Z. 6 and 9 are 15 plus another Z, which the 1 is implied. So 15, 16 is going to be 16Z. So when we combine that together, our negative T plus 16Z is our answer. Okay, one more. We have 5x plus 3 parentheses x plus 1 and parentheses plus 2x plus negative 9. Okay, so we only have the one variable, but we do have these parentheses here that we need to take care of. So over here, we're going to have 3x plus 1. And just so you know, I know we've got parentheses around the negative 9. That's only to be able to distinguish the fact that we're adding a negative number. And after today, I'm not going to include those parentheses. You're just going to have to see that there's a plus a negative number. I was only doing that to differentiate. But from now on, that's not going to be there. Okay, so when we have 3 times whatever's in the parentheses, we're going to go 3 times x and 3 times 1, which is going to end up being 3x plus 3. So we're going to take that and stick that right in that number. So now it's going to be 5x plus 3x plus 3 plus 2x plus, and I'll do it right now, negative 9. Okay. So our like terms are this one with the x, this one with the x, and this one with the x. And those are all addition, of course, but they're all adding positive numbers. So 5x plus 3x plus 2x is going to be 10x. And then we're going to add our constants. 3 plus negative 9 is going to be a negative 6. So 3x plus negative 6. We have combined all of this down to that. Okay. I hope that makes some sense. Let's take a look. Okay, I'm going to call it done as far as the combining like terms, but be on the lookout for very soon for another one having to do with the exponents. I know some of you have already started tackling the exponents, but I want to make sure that you guys have my take on how to do it, because my take is going to be a little bit different, I think. And hopefully a little bit easier. So let me see here. Ooh. There we go. Okay, let me turn this light back on. Okay, covered a lot of ground today, and I'm tired. So I want to go ahead and go to bed and be fresh tomorrow. But I'm going to be making some more of these videos. Hopefully they'll be able to help you out with it. And you know, answer more questions than they make you ask. But I think we did good today. I think we covered a lot of stuff, and I think I made it pretty clear, and I hope you got it. All right, so I will see you on Zoom. All right.